love advanced chemistry? Or have you ever been looking the online training center or institutions online school which can train you the beauty of advanced chemistry? Possibly, those are some of the questions that are going on in your mind. And I want to tell you that if you have such kind of the questions, or you can even ask yourself such kind of the questions, I would like to tell you that today you met with a fantastic and a right answer for that question or for those questions, for the number of the questions that you're asking yourself. How are you, everybody who is watching this video? I would like to take this opportunity to welcome all the national and international viewers, and I would like to welcome all the registered students of TOASO and also non-registered students. I would like to welcome everybody, the parents who are interested in these programs to check what their kids are learning. If you're guardians, if you're maybe just you're a scientist, you're a chemist, you're a pharmacist, you're a doctor of medicine, I would like to take this opportunity to welcome. This is Olenjolai, Mokota Yelo Single. Simply just call me Olenjolai. I thank God by His own grace, He built just the knowledge and skills of science, especially that in chemistry and the physics, but it also have the fundamental skills in biology, but it's own grace. But I thank God also that He built in His gift, His gift of teaching in my heart. So teaching for me, it's me, and I am teaching, and teaching is me. That's a simple phrase or simple relationship between Olenjolai and the teaching industry. So I'll be teaching you in this program. I'll be your teacher. And remember that Olenjolai does not know everything about advanced chemistry. I just know small portions of it. I'm always learning new concepts day after day, informally, not formally. And the great teacher of mine is the Holy Spirit. Okay, so but another thing is what I want to tell you, and I want just to introduce to you. I have a responsibility to teach others what I know. That's all. I know small portions of advanced chemistry, but I have a responsibility to teach others about what I know. So what am I going to teach you is I'm going to teach you what I know at this moment. It doesn't mean that after 10 years you will find me in the same phrase, because for me, chemistry is my life and my life is chemistry. So chemistry is one of my strategic and purposeful subject. I am a Tanzanian, and this is the national flag that is flagging. So you will find in every of offices or every places around our country, and we'd like to welcome all the international viewers to visit our country just for the purpose of learning and for the purpose also be in touch with the living God, because in our country we have a gift of living God. So the living God is living in our country. Okay, so I would like to say also the contents we are going to cover in this program are universal concepts, because it means these are the concepts about my research. Many students or millions of students are learning about this concept that I'm going to teach. So it means that it will benefit, these programs is going to benefit advanced secondary students of Form 5 and Form 6 in Tanzania, and even also high school students in some Africa, in all the African countries, in every continent, so they can benefit from this program. So what I want to tell you in advance, get prepared to love advanced chemistry, because what am I going to teach you? The beauty of advanced chemistry. So let me take you just a minute into our online programs. So we thank God by His own grace, He founded the Tanzania Online Advanced Secondary School in square bracket Olenjolai M. So here we have M. Okay, so M. This is initial name of the founders of our institution. I would like to take this opportunity simultaneously to welcome you into one of our official YouTube channel that's called the Tanzania Online A-Level Secondary School in square bracket Olenjolai M. What are we doing? What the purpose of Tanzania Online Advanced Secondary School in square bracket Olenjolai M? Yeah, okay. Actually, we have a great picture built in our mind concerning about these programs or concerning about this online institution, but simply say that we have an assignment, or Olenjolai has an assignment to teach and train advanced secondary students on how they can extract knowledge, understanding, and wisdom in science and mathematics for advanced level, and combine it with knowledge and understanding we are going to teach them on how they can extract it from the Word of God written in the Holy Bible. in order to solve real life problems. That is what we are going to do. So the vision we have in our mind, it has four main parts, which I know, and according to my research, it might be for the Tanzanians, maybe you have only one part or two parts. It's difficult for you to think about the combinations of those four main parts of our vision. But possibly you have your own visions, that's you. Okay, so the visions, we can break it down into four parts. The first part will teach you on how you can extract knowledge, understanding, and wisdom from the classroom instructions in advanced chemistry, advanced mathematics, advanced physics, and basic applied mathematics for this moment. So we won't teach you only just to pass exam, to extract knowledge, understanding, and wisdom. That's the first part. The second part will teach you also how you can extract knowledge, understanding, and wisdom from the manual, from our mankind manual, which is called the Holy Bible. And then the third part, to combine, to mix it, right? And then the first part of our vision, solving a real life problem. So we have different scales of real life problems, but because we are advanced secondary students, you have to think it to solve at least the small scale real life problems and the intermediate scale real life problem. You have to drive yourself and think outside the box that advanced education does not have real life applications. I want to prove to you, and I will be proving to you day after day, that it's not true. Advanced education can solve real life problems. It depends to the person who wants to convey it, because even people who are solving real life problems, they get the normal educations like the one you are getting, but then they took procedures to extract knowledge, understanding, and wisdom in order to solve that particular real life problems. For example, right now we have just this blackboard. It's somebody's solutions who has been solving the real life problems. He found that the humankind just they want to learn, but they don't have a place to write in order to copy. This book, it's a solutions which it has been in the mind of the persons, and also this book will also pursue the advanced secondary education. So there's no any excuse, my dear students, and we'll be cancelling every kind of the excuse, whether you want or you don't want, as long as you'll be in touch with us, because that's our responsibility. But we have also some specific objective. To prepare you to pass your continuous assessment, it's one of our specific objectives. Prepare you to pass your next exams, it's one of specific objectives. To prepare you just to master, to enjoy, just to get entertained with advanced chemistry, advanced physics, advanced mathematics. Solving questions for you or teaching you how you can solve questions, it's one of our specific objectives. But those are not our main objective. Our main objective to teach our students, even for 3, 4, 5 years, on how they have to convey the classroom instructions to solve real life problems. Okay, are you ready? So again, another thing like right now, if you are unregistered students into ASO, then follow these 5 steps that I'm going to present to you in order for you to register yourself permanently. The first step, we ask you to create or open a new email address, right? So we used to have an address when you are maybe primary school, the PO box, and I think even now you're still using it. The second step, you should have to make sure that in your receiving device there is YouTube software. So again, another thing, we ask you to sign in YouTube by your email. So the email we ask you means the YouTube will ask you the password and the user. Afterwards, then we ask you to say to us, don't write to us, it's not there. What it is, what name are we using in YouTube? Our official name is Tanzania Online A-Level Secondary School in square bracket Olenjolai. But to us, it's abbreviations of Tanzania Online A-Level Secondary School in square bracket Olenjolai. Once you search, it depends. If you're using mobile device, these are the algorithms that you're going to find. Or if you're using the PC, it means that it's the personal computer, laptops, desktop, MacBook, then this is the arrangements, or this is what you'll find, or you'll face it. It's a round buttons. You'll find that round buttons, there's a national flag to indicate that this is real and on a Tanzanian online school. And then we have also another national flag here of this point, okay? And then you find some very important information, name of our official YouTube channel, the number of videos. We thank God right now we've uploaded or we've published more than 120 videos, but we have a vision to record and publish them more than 600 videos, and that is our gift to the Tanzanians, but it's our free willing sense giving to our God who has built in the gift of teaching in me, because I've never learned any techniques or anything else, or any modules or any subject about teaching formally. So God has taught me about techniques of teaching informally. Okay? So that's what the meaning of gift is. So the gift is because I told you, Olenjolai is teaching and teaching is Olenjolai. And it's one of the business that I'll do for the rest of my life. So don't disgrade me because of the some teachers that you see in the street who are not satisfied with teaching, because teaching, it's not building them. So if they are complaining, they say the teaching center is non-valuable business, that's them. But to me, it's the most important industry. Okay, so once you are there, we just call this one, you are now in our poster, means that our TOASUS poster. So in order for you to get in, you are still at the poster, means at you are at the entrance gate. So we ask you to click on round button, either this, if you're using a computer, or if you're using mobile phones, you click these buttons. Once you click, you will see horizontal toolbar, written forms, videos, playlist, community, and the community channels a lot and about. But you see also a trailer video, and then you see also the uploads, so recent uploads, and you see the videos or with their thumbnail. So look or find the buttons written subscribe, right? If you are unregistered. If you are registered, the students keep these information or just listen for advantage of sharing with your friends. So click that button written subscribe, click it once. Then you find that the text will change into subscribing, and the icon of the bell will appear. And then you find that we prompted with 3 options, choose the options of all. From there, we have given YouTube permissions to give you any notifications at any time and anywhere whenever we add a new video. And I want to tell you, we are very serious in this program, and we ask you also to be serious online, because we'll be adding at least 1 video in a day in order to train our 8 classes, because we are teaching 8 subjects of advanced level or advanced education. Then now you have registered, congratulations, you're welcome, congratulations. Then take advantage. How can you take advantage of free registration? Because you don't pay anything else for you to register. You don't pay anything else to get these contents. You don't pay me anything else. I'd say this is my free will thanksgiving to God, who has built the gift of teaching in me. So I'm giving him thanks. So this is whenever I teach, I'm saying, God, thank you. And whenever you know that the advantage of saying thank you, then he's going to give me more. Okay. So the first step, the 6th step now, to take advantage, we ask you to click, just to come into this horizontal toolbar, where you can find either 5 weights or 6 weights, it depends. Then click playlisting, and then find the playlist written as the base and salts. There you will find the collections of all the videos that will be teaching you about acid, base, and salty for advanced level in a systematic way or in a systematic order. Then again, I know you'll enjoy our contest. You're asking your questions yourself how I can share. Just find the icons of share below at your right hand side, and then click it in order to share the video links to your friends or any social media that you might be using. Again, another thing that I know that many Tanzanian students, they are afraid to learn online, because they used to ask themselves so many questions. How am I going to ask the questions? How am I going to interact with the teacher? That's a good question. If you check at the bottoms of this video, you'll see a place written comments. Have you seen comments? So this part of comments, it's a part where we can meet, we can interact, myself as a teacher and you as a student, right? And also you can interact with another student. So simply here you can formulate a triangle. So this is student 1, this is teacher, this is, so you can form a notebook. This is student 2, this is student 3. So you can interact and ask each other questions, even in what in this YouTube software by using the comment section. So use the comment sections as well as you can. If you have never tried it, don't worry, and don't cancel. Don't tell your mind that nobody who is going to read your comments. I don't know about other students and other teachers or other members of TOASO, but I know myself that I will take my time and read your comments. Also, give us testimony, give us feedback if you understand. So use the comment sections to tell us, to give us a testimony. How is this program is helping you? What did you find? What can we improve? Okay? Wonderful. So if that's the case now, I believe that you are well prepared. So let us go inside today's session, which is session 3. So ladies and gentlemen, I would like to welcome you into the Departments of Advanced Chemistry. The subject is called Advanced Chemistry. The main topic is the second main topic, which is called physical chemistry, because in chemistry we have 7 main topics. So physical chemistry, we can say the second main topics after general chemistry. This is according to, remember, I'll be using the syllabus of United Republic of Tanzania, should have it beside. This is the chemistry syllabus for advanced secondary education, Form 5 and Form 6 books that have been prepared by Tanzania Institute of Education. Should have this one, right? And this is some of 40 reference books. So these contents which I'm going to teach you, I would like to dedicate, or these are dedicated, I would like to dedicate all learners are the pre-Form 60, Form 60, Grade 12, QT students, reciters, and teachers, and others who will be interested. And for advanced secondary education, also as advanced secondary students who are pursuing PCB, PGM, PCB, PCM, CBG, CBA, CBM. So we are teaching students of these 5 combinations in the national level and even international level. All right, then we are in chapter 5 of 40 of physical chemistry, which is called electrochemistry. The first one is just called the state of matter. The second one is called the chemical equilibrium. The third one is called the chemical kinetics. The fourth one is called the fourth one is called the thermochemistry. Okay, and the fifth one is called the electrochemistry. So this is session 3. I'm going to teach about degree of dissociations of acid and base, and we'll be focusing on weak and base, weak acid and weak base. Okay, so let us go into the sessions. I think that you are ready. Take your exercise book, your pen, your book. Let us go inside. Okay, so ladies and gentlemen, what you have here today, let us start with with corrections of homework 2. Homework 2, I asked you 3 questions. The first 2 questions is define the term degree of dissociation. And the second questions, I asked you to state Ostwald laws of dilution. Okay? And then the third questions, I asked you to define law of mass action. So I'll be answering those questions as long as I'll be continuing in this session. And let us go right now, because I know one of the applications of electrochemistry is pharmaceutical. So this is Panadol dose, right? These are the 10 tablets of Panadol which have been manufactured by using the weak acid, weak electrolytes, right? Because I've given you reasons that we're using weak electrolytes because unless toxic compared to the strong electrolytes. And the weak electrolytes, remember that so I have to do a quick review. So basically what we have been discussing there, we define the terms of electrochemistry. Okay, so this is quick review of session 2, electrochemistry. And then we define the terms which is called the electrolyte, the electrolytes. What's the meaning of electrolyte? And then we define, we discussed the 2 types of electrolytes, which we started with strong electrolytes. So this is the type of electrolyte which dissociate completely in the aqueous solutions to form free ions. An example, strong electrolyte is hydrochloric acid. Then we talked about weak electrolyte. Okay, weak electrolyte. So weak electrolyte, we say that this type is an electrolyte which is dissociating partially in the aqueous solutions to form free ions. So example is ammonium hydroxide. And the example 40 of weak electrolyte. So that's what we've been defined, and then we gave you examples of so many examples of strong electrolyte, okay, strong electrolytes, and then also we gave you so many examples of weak electrolyte, okay, weak electrolyte. So in case you missed this session 2, it's still in air, so you can access in any telecommunication tower. By using the power of the internet or in any fiber internet connection, you can access this content for you at any time and anywhere. Let us go into today's session. So corrections of homework 2. We answer those questions and I will give you indications. I believe that you've done it, you've tried, So it's better if we do correction in order for you to know whether you succeeded to get the right answer or you missed it. So let me start with the first term, which you call it 3.1, which is called the dissociation. Let us, because the title of these sessions is called the degree of dissociation. So let us start with the 10 first thing, dissociation. Okay, what the means of dissociation in chemistry? So we have a fundamental questions for Olenjolai. What is dissociation in chemistry? What is dissociation? What is dissociation? What is dissociation in chemistry? Okay, so I say that in chemistry, we say that the word dissociation, okay, simply say that dissociation is a process, is a breaking up, of what? Of a compound. So remember that compounds, we have compounds in chemistry of a compound into simpler. So this is breaking up the compounds into simpler constituents. Constituents that are usually capable of what? Of recombining. So these simpler constituents, they are capable to recombining under other conditions. So that the means of dissociation is a breaking up of a compound into simpler constituents that are usually capable of recombining under other conditions. The means of dissociation. So in chemistry, the word dissociation is a breaking up of a compound. So breaking up of a compound into simpler constituents that are usually capable of recombining under other conditions. Okay, so let me give example of dissociation. Example of dissociation that, for example, we have the samaic acid. It can dissociate. Okay, it can dissociate to form what? To form a cyanoate ion plus what? Hydrogen ion. This is aqueous. So listen, it has been a compound which is called the acetic acid or a samaic acid. So for this process or for this situation, it is broken. It means that these compounds has undergo breaking up to form what? Simpler constituents. So these are the simpler constituents. Simpler constituents. While this one is what? This is the compound. So a compound dissociated to form simpler constituents, which is cyanoate ions and hydrogen ions. But also these simpler constituents can recombine. That the means of these reversible reactions, backward reaction. So it means that when the dissociation takes place with only a single atom, but also under certain conditions, these can recombine to form what? A reactant. So this will change. So it means that if we consider for the direction, this is reactant, this is products. And then if you consider reverse directions of the reaction, These two are the reactants, while this one is what? It's a product. So that's the corrections of what? Of the first question. No, the first question I think that I asked you about degree of dissociation. Okay, whatever the case, because I'm going to define those. Pause the video, list these steps that you have to follow, apply them right now, and also share with other students about how they can get advantage of the answer. So ladies and gentlemen, if that's the case, right now, let us go. Let's go inside of this fantastic program. Okay? So that is about dissociation. Then we have another terminology in chemistry called 3.2, degree of dissociation. So we know the meaning of dissociation, and we have to think about degree of what? Of dissociation. First of all, the word degree does not mean bachelor. Maybe there are words that will be awarded in your university exams. No, this is just a term. Degree of what? Of dissociation. So we have a fundamental question for Olenjolai. What is degree of dissociation? What is degree of what? Of dissociation. So degree of dissociation, from different books, degree of dissociation we say that is the extent or percentage, to which a fraction of electrolyte is the extent or percentage to which electrolyte is the extent or percentage to which a fraction of electrolyte. So we say that is degree of dissociation is extent or percentage to which a fraction of electrolyte that has been dissociated of electrolyte that has been dissociated. So the extent or percentage to which the fractions of electrolyte that has been dissociated to form free ions. Okay, so let me put a pause and teach you. Yeah, okay, put a pause. Take a pause. What is degree of dissociation? Very important concept in advanced chemistry. Degree of dissociation is the extent or percentage to which fraction of electrolyte that has been dissociated in aqueous solution to form what? Free ions. So degree of dissociation, we say that in, for example, here we have electrolyte. Right? This electrolyte, we want to put it into aqueous solution. So electrolyte plus what? Aqueous solution. To see if this electrolyte will dissociate or not. Then after dissociation, here we are going to form what? Small extent, and this small extent may be expressed in percentage of what? Of electron. Because it means that form the free ions. Form the free ions. So that's the concept you have to bear in your mind. So you say free ions means it's a small fraction. It's a small fraction. For example, suppose that here you have 100% percentage of concentrations of a particular electrolyte. But on this side, maybe you can find only 1% is forming the free ions. So 1% is a fraction of 100%. So that's the meaning of what of degree of dissociation. So degree of dissociation actually is a extent or percentage to which fractions of electrolyte that has been dissociated to form what? Free ions. Okay? You understand? If you have any question, then just ask in the comment section. Okay. So now you know the meaning of degree of dissociation. And ladies and gentlemen, I don't want to state you to learn about Osterwald dilution law. Some of the books you study Osterwald dissociation law, something like that. Okay. So that is 6.3. Oh no, 3.3. So let's teach you about it. Osterwald. Okay, Osterwald law, or we call it Osterwald dilution law. Osterwald dilution law. Osterwald dilution law. Okay? Say Osterwald dilution law. This is one of the chemists who has discussed the concepts of degree of dissociation of weak electrolytes. Okay? Okay, so we have a question here, which is question 3 of the homework. State Osterwald's law. Osterwald dilution law. State Osterwald dilution law. So this is the state. Osterwald dilution law state that at infinite dilution, the weak electrolyte undergoes completely ionization. So that is how we state Osterwald laws. Osterwald laws, or Osterwald dilution law, is stated that at infinite dilution. So when dilution reached to the infinity, which is something called at equilibrium, the weak electrolyte undergoes complete ionization. if the chemical reactions of the weak electrolytes can reach at infinite dilution, then from there, any weak electrolyte that is reached in such infinite condition, such infinite dilution, then we say that it will dissociate completely to form what? Ions or free ions. Or some references also define or state Ostwald laws according to his equation. So we say that Ostwald dilution law state that the degree of dissociation of weak electrolyte is inversely proportional to the square root of its concentration. Is inversely proportional to what? Proportional to the square root of its concentration. So inversely proportional. The degree of dissociation, of the weak electrolyte is inversely proportional to the square root of what? To the square root of concentration. Of its concentration. So this is another way to state. So the law state that, second state, also the dilution law state that the degree of dissociation of weak electrolyte is inversely proportional to the square root of its concentration. And we'll prove this. Then the next item that was one of the questions of the homework is about stating the law of mass action. If you learned about chemical radium, then you realize. Okay. So the first concept is the derivation of derivation of formula for degree of dissociation. Formula of the derivation of the formula of degree of dissociation. That's what we want to teach you. Sometimes in some of the books, this one we call it the Ostwald equation. Ostwald equation. Ostwald equation. Or we call it the formula of degree of dissociation. Okay? Okay. So you see that so it means that this formula can be derived by using Ostwald's law of dilution. Okay. So remember that how many types of weak acid and how many types of weak acid we are discussing here? Basically, two main types: acidic weak, or we are discussing about weak acid and weak base. So even determining expressions, it may have minor differences. Okay? So remember that all the reactions in this part are reversible reactions. Few of them are just direct, but something to challenge you. Okay? So if that's the case, you say that, okay, so we like to think about it. So let us think about degree of dissociation of acid. Degree of dissociation of what? Weak acid. So we can derive the general formula by using only letters, or we can take an example of the weak acid, then we use it to derive the formula. So you have either of the two options. Okay. Okay. So degree of so you say that let AB undergo dissociation from A ions and B ions. Okay. So these are the ions in the product side. But also these, they can be combined to form what? AB. Okay. So if that's the case, you say that, listen carefully. Before dissociation, here we had 100. While on this side, when the reactions take place, we get 0. So B is equal to 100%, there are 0%. So before dissociation, this is 100%, while this is 0 and the other one is 0 also. Or in other ways. Okay, so we see that before dissociation, we say that we have 100%, so, and then it produces what, 0% and 0%. Okay? Okay, so that is this is the process. So we say that after time, so this is happening when the time is equal to 0. When time is equal to what? To 0. Okay, when time is equal to 0. Keep enjoying the beauty of advanced chemistry. My dear student, let us continue this very important part of mathematical derivation, where that I have to teach you how you can derive the formula of degree of dissociation. So this formula can be derived by using Oswald laws of dilution, and then we came down here, this is 3.41, is stated as degree of dissociation of weak acid. So suppose that this is the reaction, so this is the compound, so remember that this we call it the compound, which is weak acid, so weak acid compound, and these are the free ions. So these are the free ions. So we say that these reactions will take place, so listen carefully. So let me clarify, let me repeat it so you may understand. So we say that the general visible chemical reaction or chemical equation of what? Of weak acid is given as what? Remember that on the left hand side we have weak acid compound. So this is called weak acid compounds, and then we have a visible reaction to form what? Free ions. So let the compounds to be or consisting at least two components. So if these compounds undergo forward reaction, it will form 2 free ions. So this might be for the acid, A usually used to be, for the weak acid, A usually used to be negative ions, and while B used to be positive ion. But A and B means the negative ion A and positive ion B, they can recombine to form AB. So that's what we call the reversibility reaction. So we are the chemists, and also we have been learning about we have learned about the time where the reactions have taken place. So let us focus on this. So let us focus on these steps that have to follow. So this is the general question. So I said that the second step, this is the first step. So we call the general. So this is the first step. So the second step, we say that before the weak compound, before the weak acid dissociate in solution or in aqueous solution, then there is no free ions. So no free ions and no concentration for that. What does this mean? Before dissociation, we had AB. When it undergoes the visible reaction, we have 100% of concentrations, okay? And then here we expected to have A, but unfortunately because the reaction didn't take place, so the concentrations of A is 0%, and the concentrations of B is what? Is 0%. So 100%, this we say that, but this is only, so we have this state 0% when time is equal to 0. So at time is equal to 0, we don't have any free ions. Also, this we can present as 1, okay? 1, or we present as C, just initial concentration. So this is still 0, okay? So we present at 0%, and this one also 0%. So 0 over 100 is 0, and yet is 0, when time is equal to 0. So in a simple chemistry language, we say C stands for the initial concentration. So this is initial concentration. Okay, initial concentration. So we say that here the time is equal to, so initial concentration when C, okay, initial concentration. So you have the free ions there. So here is 0 and 0 at the time is equal to 0. Okay, so that's the second step. So you go for the third step. The reactions will take the third step. So third step, we say that when weak acid dissociate to form what? To form free ions. So now in products we have free ions. So in reactant side we have AB. So this undergo visible reaction. We have A as negative ions and B as positive ions. So here we had what? Concentration. So right now, listen, we are going to have what? 1 minus degree of dissociation times initial concentration. This is concentrations of the undissociated weak acid. So the concept, because this weak acid now it is dissociated and then it's forming what? So let me just go slowly. So the weak acid dissociates and form the fractions of the weak acid dissociate to form alpha. Alpha as a degree of dissociation, and here also you have alpha. So if you have alpha, we don't say that you have 2 alpha, no. So because sometimes you find concentrations of anions is equal to concentration of cation. For that case in chemistry, we say that the concentrations of AB, which is undissociated, not the concentration, means the number of atoms or the fraction. So the large fraction didn't dissociate, while the small fractions has dissociated. So if that's the case now, we have the left hand side and right hand side. If you multiply with initial concentration C, then we have what? 1 minus alpha times C, you have alpha times C, and there we have alpha times C. This will take place at time, when time is equal to time t, and this will also take place when time is equal to time t. Okay? So that's the point. So the point that you have to note right now, in our journal of the revision, okay, so simply say, ladies and gentlemen, we have a weak acid here, undergo the visible reaction to form what? Anion A and the cation B. So this is 1 minus alpha times what? Initial concentration C, here alpha times C, here alpha times C. So this is, remember, so we go into the first step of derivation. First step of derivation, we say that at equilibrium, we say that at equilibrium, so at equilibrium, say that the ratio for it, so at equilibrium, okay, so let me just say. So when the reaction above reaches, because that process continues until the number of atoms on the left hand side is equal to the number of atoms on the right hand side. It means there's no any further dissociation. So when the reactions above reaches at equilibrium, then the law of mass action can be applied. Law of mass action can be applied. So from there now, you have a question. I think that this is question 4. State the law of mass action. The law of mass action. I believe that if you're a Form 6 student, then you're enjoying our contents that we're teaching you. The law of mass action is not new. If you've covered about chemical equilibriums, then you met it in as one of the Taylor's principle. So this is the law of mass action. Okay, the law of mass action states that when, so it states the law of mass action. Okay, so pause the video and then think for a moment, how can you state that law? Okay, so you have to think how we can state law of mass action. So ladies and gentlemen, the answer is law of mass action state that, then we cut, when we cut, state law of mass action. Law of mass action. Let me check one of my reference. State that it is a proportion. It is a proportion. It is a proportion that the rate of the chemical reaction is directly proportional to the product of the concentrations, the product of what? Of the concentrations of reactants. This is the end of the statement. Okay, so the question asks us, we have to state the law of mass action. So the law of mass action states that it's a proportion that the rate of the chemical reaction is very proportional to the product of concentrations of what? Of reactants. So if you have a phenomenon of very proportional, it means that there is proportionality constant. And that proportionality constant, we call it equilibrium constant. Okay? Equilibrium constant. So that is what we call law of mass action in chemistry. So remember that what am I teaching you? I'm teaching you how you can derive the formula that can help you to find the degree of dissociation of weak acid. So this will give us an option. So when the reactions reaches at equilibriums, then the law of mass actions is what can be applied. So it means that we say from what? From the fact that equilibrium constant K is equal to the concentrations of product per a certain number, let's say power n, of what? Concentrations of reactants power m. Okay? So where remember that K is what? It's equilibrium constant, where K is equilibrium constant of reversible reaction. So for that case, you say that let Ka to be what? Dissociation constant of what? Of acid by the means of this subscript A. So if that the case also, we say that dissociation constant of the acid is equal to concentrations of the product, or products, means product 1, product 2, K power n over concentrations of reactants power n. Okay? So simply say that, suppose we have that equilibrium, so we say that from the given chemical reactions there, we say that Ka, the dissociation constant of AB, is equal to products of concentrations of A as negative ions multiplied by concentrations of what? Of B ions, divided by concentrations of what? Of AB. So anion A and cation B are the products, and then say B, it's a reactant. So for that case now, if you substitute with these concentrations, final concentration, then this is at time is equal to T. So this we call them final concentration. So in this one we say that we get what? Alpha C times what? Alpha C divided by what? Divided by 1 minus alpha multiplied by C. C, it's initial concentration. So you say the constant of an acid is equal to what? Alpha square, C square, over what? 1 minus alpha times C. So C and C cancel. This will make degree of dissociation square times initial concentration over what? 1 minus degree of dissociation. Okay? So we are still deducing our common formula that we'll be using to solve problems in most cases. So I'm spending some time on deriving the formula of calculating the degree of dissociations of an acid, because when I'll teach you the derivations of the formula for degree of dissociation of a base, then I'll skip some steps because you know. So the dissociation constant of an acid is equal to alpha square times what? Initial concentration 1 minus what? Alpha. So suppose that this is equation 2. So the equation 1, you might say that this was the equation 1. Okay. So if that's the case, you say what? So you go into what? We have been in what? In a first step. So the first step of derivation. These steps are very important because later on when you do revision of what I'm teaching right now, your revisions will be very smooth because you know in each step what you have done, and because I wrote and also you have to write in order to memorize and to remember how did you jump from the first line to the second line. So the first step we say that the value of the degree of dissociation is very small, smaller than 1. So it is in terms of what? So it is 0.0000001, possibly 2. For that case, if you use your scientific calculator, 1 minus a very small number, this will give us what? A response which is equivalent to 1. If you want to prove, just take it from your scientific calculator to 1 minus 1 exponent negative 99. You get the answer, the limit will be 1. So use your scientific calculator. That's your quiz. So for that case, it means 1 minus alpha, this is equal to what? To 1. So if that's the case, ladies and gentlemen, Ka, this is subscript. So degree of dissociation of acid is equal to alpha square of what? Over C. Alright? Why? So over C, degree of square of the degree of dissociation times C over 1. So this simply give you degree of dissociation square times initial concentration. So this is very important formula in your life of electrochemistry. So take a note. Okay? So whereby what? Whereby Ka, this is what? Dissociation constant. Dissociation constant of what? Of acid. And then you have what? C. This is initial concentration. Initial concentration. Then you have alpha. Alpha, this is what? Degree of dissociation. Degree of dissociation. Okay, degree of dissociation. Also, you can rewrite this formula in another form. You have dissociation constant of acid is equal to alpha square C, right? So you may divide by C to both sides. So divide by C and C. So you have dissociation constant of the acid over initial concentration is equal to the square of degree of dissociation. Then you can find square root. So if you find the square root, then from here we find that the formula of finding degree of dissociation of the weak acid is given as ratio of dissociation constant of acid over initial concentration of the acid. This also a very important formula for your life. Okay. Another point or another step which will be the okay, so we have finished about that. We'll be focusing on what right now we'll be focusing on the concentrations of hydrogen ion. Okay. So one of the free ions that will be formed when the weak acid dissociate is called the hydrogen ions. So this is what the 60th step. The 60th step we are focused on what? On concentration. Okay? So say that from reversible reaction above, we have what? Above, the final concentrations or molarity, concentration final concentrations are the final concentrations for the weak acid AB, which is the compound. This is equal to 1 minus degree of dissociation times initial concentration. The final concentration for an ion, or for the negative ion, this is given some degree of dissociation times what? Initial concentration. The final concentration of what? Of B positive, which in most cases will be hydrogen ions, is alpha times C. Okay? So you have to note. Okay? When the weak acid dissociate, then HC cation, it's an ion, this cation B is always what? Always hydrogen ion. Hydrogen ion. So for that case, concentrations of B positive, this is equal to concentrations of hydrogen ion. I'll give you examples. So this is equal to what? Degree of dissociation times initial concentration. Okay, we'll be focusing on this. However, that's some questions that will ask you to find the final concentrations of free ions and the final concentrations of what? Of reactants. I believe that you're enjoying these contents and enjoying the beauty of electrochemistry and enjoying the beauty of physical chemistry, which is a cornerstone of farmers. It's a cornerstone of what? Of farmers. So if we continue a little bit with these concentrations of hydrogen ions, it's equal to degree of dissociation times C. So suppose that this is equation 3, or this is equation 4. Equation 4, and then suppose this as equation 3. So there is a relationship, mathematical relation between equation 3 and equation 4. So what if we don't know the degree of dissociation? Or what if we don't know we don't know the initial concentration, but we know the dissociation constant? So it means that for this case, we may go to the 7th step. The 7th step, we say that substitute. So substitute equation 3 into equation 4. Okay? So if you substitute here, you have concentration of hydrogen ions. This is equal to alpha C, what the value of alpha is the square root of what? Dissociation constant of acid over initial concentration multiplied by what? Initial concentration. So if that's the case, here we have concentrations of hydrogen ion. This is equal to what? So here we have initial concentration square root of Ka over initial concentration. So this we say that because C is outside of the square root, is if we take C initial concentration into inside of the square root, then this C should be squared because we form the square root of C squared, then we got C. And then we find what inside. It's the constant of acid over initial concentration. So this one and this one cancel. So for that case, we say that concentration of hydrogen ions is equal to the square root of what? Initial concentration times what? Ka. So this is the very important general formula in this topic. You should remember it. So you have 3 questions. So you say that whereby what? Whereby this is what? Concentration Concentrations of what? Of hydrogen ion. Okay, so that's all. Now let us think about base. How about base? That is all about what? About acid. So you can pause the video and do the same derivation, but we have just to change the general formula with base. So for serious students, you can just pause the video and then use the graph paper to try to derive the formula of determining degree of dissociation of 40 of weak base. Okay? So if that's the case, you say that let us go into that concept. Derivation of formula of what? Degree of dissociation, and what? And the concentration of hydroxide in base. Okay? Just to prove this formula, remember, it means I want to prove this formula that it works for any dissociation of weak acid. So it is associated with A, then B, and this one. So, for example, we have dissociations of methanoic acid. So it undergoes reversible reaction. Okay? And hence you know what it will form. So simply it will form. So this is equivalent to A. And this is equivalent to B. So it will form what? It will form methanoic ion. This is called methanoic ion plus hydrogen ion. So an ion. Okay? So if that's the case now, we will be following some steps. So the first step, recall what? Recall general, invisible reaction of what? Of weak base. So we say that suppose we have C, D. If weak base dissociate, then C will become cation and D will become anion. This is the minor difference between these general formulas. Example, when ammonium hydroxide dissociate. So when ammonium hydroxide dissociate, we form what? So this ammonia ion will be equivalent to C. Then these hydroxide ions will be equivalent to what? To D. So when dissociate, it will form what? Ammonium ion plus what? Hydroxide ion. So this is equivalent to, they said, this was C and this D. So after dissociation, you find that this C become positive and this D become what? Negative. It's quite different from what? From weak acid. Because when weak acid dissociate A, the first part of the compounds, which you call a negative part, becomes a negative, and the second becomes the positive. So these formulas, they don't obey associative law in mathematics. So you have to understand this. It means if you are writing these reversible reactions, and if you alternate, okay, it will be the same, but you might get confused. Okay? So that they're taken to identify the cations and anion. And this formula is that formula of the equation, that general formula of the equation is applicable to all weak bases. Okay? So then we go to the second step. Second step, we say that at the initial state of what? Of the reaction. No free ions. But the free ions here is C and D. Free ions here is ammonia ion and the hydroxide ion. Okay? So no free ions. So it means we have C, D. We didn't undergo reversible reaction, right? So it means that we're expected to have C positive ion and D negative ion. So for that case, we say here we have 100% of the compound. Why on this side we have 0% of the compound and we have 0% of this compound? Here when the time is equal to 0. This 100% also you can write this 1, and here we have 0, and here we have 0 when time is equal to 0 seconds. That is the stage where the chemical reaction did not take place. Okay? At the stage where the chemical reaction, or when the weak base did not dissociate. Okay. So if that's the case, we go to the steady state. So the steady state now, after time t, excuse me for some external noises in this place, but concentrate on what I'm teaching you. So we go for the steady state. Steady state, say that at time T, the final concentrations are, so we have CD undergo reversible reaction to form C ions, positive ion, and D negative ion. So before it was 1, here it was 0, when time is equal to 0. When time is equal to T. So 1, CD dissociate, and the small fractions of CD will form C positive ions and D positive ions. That small percentage is what we call the degree of dissociation, alpha. And this degree of dissociation, alpha. So then for that case, when this one will be formed, so where do we get alpha? Alpha, we get it from what is CD. So on the reactant side, what will be remaining is 1 minus alpha. This is a simple. For example, in case that you have 10,000, then you use 4,000 to buy some food. Then what will be the remainder? The remainder will be 10,000 minus 4,000, which is 6,000. So suppose that this is 4,000, this is 4,000. Don't consider that these are the two 4,000, this is the 8,000. No, this is 1 4,000, because the concentrations of C, positive C and negative D is the same. Okay, so you have 1 minus what? But this is not concentrations, this is degree of dissociation, or we call it number of moles. Number of moles from the free ions and number of moles remaining. So to get the molarity, which you call the final concentration, so you take 1 minus alpha, we multiply by initial concentrations of CD, and here we have alpha times C, and alpha times C, and this is when time is equal to time. Then we say at equilibrium, so we go for the first step. So we say that when reaction reaches at equilibrium, then what? Then we say the law of mass actions can be applicable, or the Taylor principle can be applicable. So it means that we say that dissociation constant, equilibrium constant is always equal to the product power n if you have more than one product, and then so here you have reactants power m, so dependent number of reactants. So for that case, we say that we who are dealing with weak base, we have to let K be to be what? To be a symbol for dissociation constant. Dissociation constant of what? Dissociation constant of base. Okay? So from the equation above, from the final concentrations of the equation above, so we say Kb will be equal to the concentration of C positive times concentration of D negative, divided by concentration of what? Concentrations of Cd. Okay? So once we have the general formula, then we can substitute the final concentrations or the values or final concentrations of each product and the value of the final concentrations of the reactant. Okay? So we say that dissociation constant of base, this is equal to what? This will be equal to, so our concentrations of C positive, concentration of C positive is alpha times C. And then concentrations of D positive is alpha times C, divided by what? Concentration of CD, which is 1 minus alpha C. So this will make what? Alpha C, alpha square, C square over what? 1 minus alpha C. C and C cancel. So C is initial concentration. Dissociation constant of base is equal to what? Square of the degree of dissociation times initial concentration over 1 minus alpha. But from the fact of mathematics, degree of chemistry, laboratory, experimentally, alpha, it's this number of moles or small fractions is very, very small compared to 1. For that reasons, if you take 1 minus alpha, as I told you, this will be equal to 1. For that case, you say that the dissociation constant of base is equal to degree of dissociation square times initial concentration over what? Over 1. Okay? Over 1. So, ladies and gentlemen, so for that case, we say that these expressions will be square of the degree of dissociation times initial concentration at the value for the formula for Kb. So Kb, so the constant of the base, is equal to alpha square times what? Initial concentration. Very important formula. So in this formula, we say that whereby Kb stands for what? Dissociation is the constant of what? Of base. And then alpha stands for what? Degree of dissociation. Degree of dissociation of base. And then C stands for initial concentration. Initial concentration. Stand for initial concentration. So remember that you can also express what? You can also find, deduce the formula for degree of dissociation. That will be your homework. So homework 3. So the homework 3. Homework 3. This will be example 4. Example 4. Given the formula of Kb is equal to alpha square times initial concentration, right? So we say that deduce the formula of what? Of finding the degree of dissociation. Very simple question. But the main, that's just like a quiz because you do it within a minute. The main purpose that not to leave you challenging homework is because we want you to spend much time on revising what we have taught you in order to master it before we teach you how you can solve problems. So right now, let us focus on this last part of this session, which derivation of what? Formula of what? Formula of concentration, because these concentrations will give us pH and pOH later, of hydroxide. Concentrations of hydroxide. Okay, which is negative anion or negative ion. So you say from CD as reducible reaction, this will give us C positive ion and D negative ion. Okay, so for example, you have what? Ammonium hydroxide. When to dissociate, it forms what? Ammonium ion plus what? Hydroxide ion. So from there, you may find that, and remember that the final concentration, here you have 1 minus alpha times initial concentration. This is alpha times initial concentration, alpha times initial concentration. That the final concentration. So if that's the case, we say that now concentration of D, which for all weak bases will be concentrations of hydroxide ion. This will find it by the formula degree of dissociation of weak acid times what? Initial concentration. If you substitute the value of alpha, that will be right there, then finally, because you understand how we can derive, finally find that the expression is the constant of base of initial concentration. So again, this is very important expression for the rest of you. My dear student, I have a lot of information to teach you about the beauty of physical chemistry and the beauty of advanced chemistry. But let me put, the Holy Spirit to say it is enough for you today, because I can overdose you. This is the end of session 3, that has been titled about degree of dissociations of acid and base. I thank God who have created me in His own image and likeness, and I thank God also who have beautied the gift of teaching in me. I give Him all the glory and praise. He deserves everything that is in me, and even yourself, you have to give Him all the glory and praise because He deserves. So I would like to ask you that in case you have any question, please don't hesitate to ask in the comment section. In case also you have any advice, share with us in the comment section. In case also we'll be giving you a homework that you need to write a chemical equation, keep praying for us. We are developing a system that can allow you to send your homeworks so I can review. But make sure that, for example, the homework I have given you is difficult. Yes, you can show it. You can show it. You can show in the comment section. So, right, send me, or just yes, send me your the solution of your homework in the comment section below there. So send it there right now. Again, ladies and gentlemen, before I end this session, I would like to share with you good news that we have in TOAL. TOAL is it's abbreviations of Tanzania Online Advanced Library, where we have several books for you. You can take advantage of them. The first one is chemistry syllabus, right? So I have chemistry syllabus, which is written as chemistry syllabus for advanced secondary education from 5 through from 6. And this one, you can order this fantastic ebook with only a price of 17,000. So possibly I told you 15,000 right now. There's an increase of buying cost. We're not doing business, we're equipping our students. So you may order this book itself with the price of 17,000. Then we have conceptual chemistry, which is famous as what? Chandi or Chandi 1. So simply this is costing 45,000 Tanzania shillings. Again, we have some other review books, which is, we call it questions and answers. We have a chemistry review book that's called the advanced level, paper 1 and advanced level, advanced review chemistry paper 1 and review chemistry paper 2. So I took them from our library. Advanced chemistry 2 review and advanced chemistry 3 review. 1, excuse me. You don't have 3. So you have to understand practical chemistry so you can write a review of paper 3. However, that in most cases there are some changes which might take place. So you have this book that comprises questions and answers from the past papers for the Tanzanians that reads problems and solutions from 2001 to 2016. So then this is also called Advanced Chemistry 2 Review. It's consistent problems and solutions from 2003 to 2018. So you may take advantage of this book. You may order this. It costs 17,000 Tanzania shillings, 17,000 Tanzania shillings. So you may find that we are not doing the business, we're equipping our students. In the local market, you can find this book with a very high cost. So you may order you may order a package like this one because the transport cost is minimum. You may order this book in any regions or any district or any ward or any village of Tanzania, and then we'll make sure that we send these books to you. We have also original scientific calculator, which is Casio function 991. The original one is costing 55,000 Tanzania shillings, and the other ones, which is not original, costs 35,000 Tanzania shillings. How can you place your order? You have to place your order by sending me an SMS through 0759 745331, and then I'll make a call to you once I receive your message of order. Then we accomplish the business. But remember, the system of payment, it's online payment, it's mobile. It means that it's mobile transaction. It's a mobile transaction, and you have to do the prepaid before we send to you the books. Take that advantage of having online library which you can access in anywhere in a country of Tanzania. But remember, there is also transport cost in order to, it means that there's transport cost when we send this book to you. But if you're in Dar es Salaam, you may just buy this book physically, and we can just deliver it to you as well as we can. Lastly, in case you feel from your heart that you want to offer our God your freely thanksgiving of anything, of any material that can be used in this program. For example, we still need computer, we still need microphones, We still need batteries. We still need lights because we want to improve the quality of lights. We still need again another contents, memory cards. So we still need a lot of materials in order to make sure that we carry on. So we are paying everyday electricity bill, the internet bill. So actually it's very expensive to produce one video, but our guard is more expensive, more valuable, or more worthy rather than the expenses that we are spending. But you are invited, doors are open day and night. Even right now, you may send your free Thanksgiving of any amount, even 50 Tanzania shillings, or 100 Tanzania shillings, or 10,000 Tanzania shillings, or 1,000 United US dollar, or maybe 10,000 euro. So you may send your feelings there, and then you have to make sure that you are sending it with a generosity. You offer it with generosity because we don't want you to offer because you had an announcement to offer, right? We want you to offer by faith and not by traditions or by experimentation or it means that or beliefs. No. So make sure that you send your feelings through that telephone number 0759 745331, and then please write me a message of the purpose because your feelings Thanksgiving will be used to pay the running cost for this program. My dear student, thank you very much. This is Olenjolai. Keep enjoying chemistry and meet you or join me in the session 4 when I'll teach you about problem solving of degree of dissociation of acid and base. Then I'll teach you another concept that's called pKa and pKb. So you may try to read those concepts in the book, and that's when I'll come, then I'll be building more foundations in your mind. So may God bless you and keep you until we meet.